1. Green leaf sifting. Green leaf sifting is essential to remove extraneous materials like stones, sand, and metal pieces. Foreign materials can cause severe damage to continuous machines in the factory. Uneven feeding of leaves into machines can cause jamming and inefficient operation. A vibrating tray with perforated holes or wire mesh is used for sifting. Powerful magnets are used to remove iron particles from the green leaf. Withered leaf should not remain in heaps for long to avoid overheating. Reducing the time between removing the leaf from troughs and sifting is important. Proper sifting ensures smooth processing in the subsequent CTC stages. Overheated leaves can negatively affect the quality of the final tea product. Regular monitoring and maintenance of the green leaf sifter is required to maintain efficiency. Second, reconditioning of tea leaves. Reconditioning involves recycling secondary grades and residues back into the withered leaf. This practice is commonly used in South Indian tea factories. Reconditioning aims to produce tea with high density and grainy grades. The amount of reconditioned dust RC varies from factory to factory. RC ratios are expressed based on the weight of the withered leaf or made tea. Calculations for RC addition depend on the moisture content of the withered leaf and RC dust. Overuse of RC dust can lead to quality issues like jamming of CTC rollers. A controlled addition of RC dust is critical to maintain tea quality. RC dust should be freshly prepared, not accumulated for long periods to avoid quality degradation. Proper grinding and mixing of RC materials ensure consistency in tea quality. 3. Moisture control in withered leaf and RC dust. Moisture content in the withered leaf should be controlled within a narrow range, 2 to 3%. Moisture content is a key factor affecting the amount of RC dust to be added. A mathematical formula is used to calculate the optimal RC material for withered leaf. Maintaining consistent moisture levels in the leaf is crucial for high-quality tea production. Withered leaf moisture content influences the appearance and density of the tea. Over-drying or under-drying the leaf can lead to poor tea quality. Regular monitoring of moisture content is essential throughout the processing stages. Excess moisture in the withered leaf can lead to improper mixing with RC dust. Controlling moisture prevents overheating and enzyme loss during the process. Consistent moisture control leads to better flavor and overall tea quality. 4th, leaf conditioning. Leaf conditioning involves shredding withered leaves into finer particles before CTC processing. A leaf shredder is used to increase rotor vein capacity and improve leaf mixing with RC dust. The pre-conditioned leaf needs to be in a chutney form for optimal processing. Regular changing of shredder blades every week ensures better leaf shredding results. Proper balance and weight of shredder blades are critical for uniform conditioning. The rotor vein, a large mincing machine, further conditions the leaf for CTC processing. Different rotor vein sizes, 8 inches and 15 inches, affect the leaf processing and crushing pressure. Pressure applied by the rotor vein ensures better fusion of RC material with the withered leaf. The leaf must be preconditioned for smooth passage through CTC rollers. Regular monitoring of rotor vein performance ensures the quality of the preconditioned leaf. 5. CTC processing. The CTC process involves mechanical crushing, tearing, and curling of tea leaves. 2 rollers with different speeds, high and low speed, are used in CTC machines. The gap between rollers, as small as 0.002 inches, is critical for precise cutting. Roller speed ratios 1 to 10 influence the quality of the tea produced. The position of the drop point behind the slow speed roller improves cutting efficiency. Increasing the number of teeth per inch, TPI, on the rollers enhances cutting action. Proper tooth profile and surface area of the rollers affect tea grain size. The crushing and curling action occurs simultaneously in CTC rollers. Closer roller settings result in more grainy and uniform tea particles. High quality CTC processing depends on precision in roller settings, speed, and maintenance. 6. CTC roller. Maintenance and sharpening. CTC rollers must be sharpened regularly to maintain tea quality. Roller sharpening is required when teeth wear exceeds 6 thou of the teeth depth. The first set of rollers should be changed after processing 0.75 lakh kilograms of green leaf. Sharpening intervals increase progressively based on leaf quantity processed. Logbooks must be maintained to track roller usage and sharpening schedules. Different sharpening angles, 65 degrees, 60 degrees, 55 degrees, produce different tea grades. Proper sharpening improves crushing, tearing, and curling actions. Double milling marks caused by machine errors should be avoided. Sharpening angles should be adjusted according to estate-specific needs. Regular inspection of rollers using depth gauges ensures uniform cuts and avoids flakiness. 7. Speed and setting ratios in CTC rollers. Roller speed ratios, high speed versus slow speed, impact the quality of the cut. Speed differentials between rollers influence particle size and tea grade consistency. Higher speed ratios, e.g. 1 to 10, produce finer tea grades. Increasing the teeth per inch, TPI, enhances cutting efficiency but affects curl quality. Setting the gap between rollers affects both cutting and crushing actions. Proper surface speed differences must be maintained between high and slow speed rollers. Using rollers of equal diameters ensures consistency in surface speed ratios. Incorrect roller size affects nip angle, resulting in uneven cutting. Regular checks of pulley size and roller diameter prevent speed imbalances. Maintaining correct speed and setting ratios improves tea yield and appearance. 8. Foreign matter and machine maintenance. Foreign materials like iron pieces must be removed before processing to prevent roller damage. Powerful magnets are installed on conveyors to catch iron particles. Magnets should be cleaned every 2 hours to ensure their effectiveness. Regular cleaning of the CTC machine is crucial to prevent bacterial infections. Washing the machine with high pressure jets must be done carefully to avoid water entering bearings. Maintenance of rolling machinery should be done daily for optimal performance. Ingesting foreign matter can cause jamming, reducing machine efficiency. Cleaning while the machine is running is hazardous and should be avoided. Proper ventilation in the rolling room reduces heat and gas buildup during processing. Maintenance logs should be kept for every machine to track cleaning and repairs. 9. Temperature and moisture. Monitoring in CTC process. The temperature after each CTC cut must be recorded every 2 hours. Maintaining temperatures below 35 degrees Celsius improves tea color and liquor quality. Overheating above 40 degrees Celsius can reduce enzyme activity, impacting tea flavor. Regular checks of leaf size and style ensure consistency in the final tea product. Moisture content should be monitored at key stages, such as shredding and after the fifth cut. After shredding, moisture levels should range between 70 to 72%. After the fifth CTC cut, moisture should be between 54 to 56%. Deviations in moisture content can result in poor leaf texture and tea quality. Maintaining proper moisture levels prevents jamming and enhances cutting efficiency. Consistent temperature and moisture control lead to better leaf fermentation and oxidation. 10. Ventilation and heat. Dissipation in rolling rooms. Proper ventilation in the rolling room is essential to maintain a safe working environment. Poor ventilation leads to the accumulation of off gases, affecting the quality of tea. Heat buildup during rolling can damage leaf texture and reduce liquor quality. Cooling the leaf after rotor-vane processing ensures better CTC performance. A spreader is used after the rotor vane to cool the leaf and feed it uniformly into CTC rollers. Reducing the temperature of the leaf before CTC improves tea texture and appearance. Ventilation systems help dissipate the heat generated during the rolling process. Regular checks on air circulation prevent overheating of both machines and tea leaves. Adequate airflow reduces the likelihood of bacterial contamination in processing machinery. Installing temperature and humidity control systems can further enhance the working environment.